First, let's understand what is a portfolio project. A portfolio project is one that you have built on a large and unique real world data set. So typically, you should not be using some toy data set like MNIST or Titanic, or a data set that is already used in a course that you're taking. For example, we use the Stack Overflow data set in the Zero to Pandas course. It should be somewhat unique. Not that it nobody has ever built a project on this topic, but there are not thousands of projects on this topic. Okay, if you search the data set and you don't find thousands of results or hundreds of results of projects on the topic, then maybe that's a good enough project. Of course, it's very hard to find a topic, a data set that is completely unique that nobody has ever worked on, although that can be done. But as long as it's not too overdone, it's okay. But the other important thing is that the data set that you work on or the topic that you pick should have a large scale. By a large scale, typically in terms of tabular data sets, we are referring to tens of thousands of rows or hundreds of thousands of rows or maybe millions of rows, because you want to showcase that you can work with large amounts of data. So that's the first part. The second thing is that this project should demonstrate your mastery over the skills in data science and machine learning that it involves. So if you want to showcase your data analysis skills, then show how you're cleaning the data, show how you're transforming data from one format into another, parsing dates, finding outliers, removing and dealing with duplicate values, working with categorical data, working with numerical data, showing how you can compute statistics on data. So try to showcase a wide range of skills in the domain while building your project and not just solve a single pointed problem. Next, you need to have good code quality and documentation, because this project will be used by potential employers to judge the kind of code that you will write once you join their company. So make sure you have proper variable names, make sure you have proper functions, make sure you have split your code into modules if it's a Python script, or organized your code properly into sections if it is a Jupyter notebook, and include proper documentation, which means you should have a README file or a description in your Jupyter notebook using Markdown cells describing what the project does. You should have an outline of the project. You should have a summary. You should have details about each step well documented. And that's what makes a great project. And finally, it's not enough if you've done your project and you have it sitting on your computer. You need to take your project and publish it online. You can publish it on Jovian, on GitHub, on LinkedIn, on a blog, wherever you want. But it's very important that you publish your project online. Otherwise, nobody will believe that you've done the project. And you should also link to your project from your resume. Nowadays, most resumes are shared in PDF form, and PDFs can include links. So if you're not linking to your project, which is published online in your resume, then that's a missed opportunity, because somebody is going to want to see your project when they come across your resume. So those are the characteristics of a portfolio project. Now, why should you build portfolio projects? Isn't it enough to just complete some course and then you can go out and apply for jobs and maybe start your career in data science? Well, one important reason for building projects is that you get hands on experience, because you are learning by doing. You are not just listening to a tutorial, you're not just answering some questions in a quiz. You are actually building a project using real world data. And that is the closest you can get to what you're going to do in a job. So, in many ways, it is a good replacement for lack of experience in the domain. So, when you get the question that you don't have experience in the domain, how do you get a job? The answer is by building projects so that you can showcase that. Second, it also helps your resume stand out. Every time a company puts up a job role, hundreds of applications are submitted within days of the job post going live. So you need your resume to stand out, because most recruiters and employers are only going to spend 5 to 10 seconds scanning a resume before they move on. So if you have two or three good high quality projects that stand out, then your resume will get shortlisted. Next, the project provides evidence of your skills. I see a lot of resumes where people just mention a whole list of skills: data analysis, machine learning, Python, NumPy, Pandas, Plotly. Now, the problem is anybody can list those skills in the resume. So, there's no way for the interviewer, no way for the recruiter or the employer to know whether you actually have those skills. And looking at your projects and checking them out online helps them get convinced that you actually do have these skills. A lot of people have told me that because they have their projects linked from their resume, their interviews have gone better because half of the interview is just a discussion about their project and how they accomplished it. So you're going to have a harder interview if you don't have a project to talk about. But having a project is going to make it a lot easier because the interviewer is already convinced to some extent that you know what you're talking about. And one other reason you may want to do a project is to acquire domain expertise quickly. Let's say you want to apply to some companies which operate in the finance domain and require data science or machine learning skills. Maybe build a project that is at the intersection of data science and finance. Similarly, for healthcare, maybe build a project that is at the intersection of data science and healthcare. So, if you want to quickly acquire enough domain expertise that you can perform well in interviews for a specific domain, a great way is to just spend a few weeks and build a great project. So, that's why you should build portfolio projects. Now, where do you find these unique real world data sets for building your projects? So there are many good sources, but my favorite one is Kaggle datasets. You just go to kaggle.com/datasets and we'll post this link in the chat. So kaggle.com/datasets is where you can find a lot of great community sourced datasets. Apart from this, you can also look online on Google Dataset Search, which can help search across millions of websites on the internet. So you just type in a topic of your choice and you can find a dataset. Next, you can use the UCI machine learning repository. Again, all the links are in the chat and the description. And finally, you can also look at specific sources for specific domains, for example, for finance or for world economic data. You can look at World Bank. And there are several other resources, several other sources of finding good data sets for specific domains. Now, as I said earlier, make sure that your data set is large enough, which means it has tens of thousands, possibly hundreds of thousands, or even millions of rows of data. And also make sure that you do a quick Google search of your data set and find that there aren't already hundreds of projects. If there are hundreds of projects on a data set, then maybe skip it, maybe find a different one. So here is the must-have project number one. This is exploratory data analysis and visualization because this is the bread and butter of every data scientist, data analyst, business analyst, product analyst, decision scientist. No matter what you're doing in data science, most of your time is spent getting data from a certain source, analyzing that data, cleaning that data, and visualizing that data. So, how do you build an exploratory data analysis and visualization project? First, pick a large real world data set using one of the dataset sources we've talked about. Then, perform data preparation and data cleaning. So, there must be some cleaning required in the data. There might be some values that were not passed properly. There might be some outliers. There might be some duplicate values, some missing values. There are lots of issues in real world data, and you should be able to demonstrate that you can work with data and clean it and prepare it for analysis. Then just analyze and visualize the process data in many different ways. You can start with every single column of data and you can analyze it. You can visualize it using histograms, bar charts, scatter plots when you're looking at two columns at a time. Then add in more color using third or fourth column. Try to gather some insights based on these analyses and the visualizations. Try to create different kinds of graphs. So at this point, you're just exploring the data set just to show everything that can be done using the data set. Next, once you've gotten a feel for the data set, ask some interesting questions about the data because ultimately data science is about asking and answering questions. And by asking and answering these questions, gather some interesting insights. And it's very important that you summarize these insights towards the end of your project. So once you work through or once you are reading through a large data set, you've analyzed it, visualized it, summarize what you have learned, especially focus on any interesting or counterintuitive insights that you were able to uncover. And finally, document your work, clean up your code, make sure you have proper variable names, functions, etc., and publish your project online. So that's how you build an exploratory data analysis project. Now let's look at a few examples. These are all created by participants of the Jovian Data Science Bootcamp, where we work together with every individual participant to make sure they build great portfolio projects before they can start applying for jobs. So here is one project created by Rohan, where he took his listening data from the platform last.fm. He took his data over several years, downloaded it, and then converted that into a CSV and analyzed it using Python. And you can see all the interesting charts that he's created. You can see the different kinds of artists that he listens to. You can see the durations of the songs that he listens to. You can see the time of day during which he listens a lot. So there are a lot of interesting insights that you can get out of just analyzing and visualizing your own data. And you can download data from Google, you can download data from Spotify, from Apple, from Facebook, Instagram, all of these places, and then you can analyze it. So that's a great example of a personal data set, and it is a large enough data set because it has 73,000 rows and 19 columns. Here is another great analysis. So Pankaj analyzed 7 million plus companies using Pandas, Matplotlib, and Plotly. And you can look at some of the graphs that he has created. So a geographical map showing where these companies are distributed. Clearly, you can see the United States has a higher volume and other countries have a slightly lower volume. You can see the industries how they have evolved over the years. You can see a trend that a lot of companies early on were in the manufacturing sector, and now a lot of them have moved into the technology sector. And you can see many other insights that can be gathered from this project. Now, we are posting the links to all of these projects in the chat, and we will also include them in the description so that you can check out the entire Jupyter notebook for each of these projects. This is just a small snapshot of the work that was done in this project, which typically went over 50 to 100 hours. Here is another analysis of weather and renewable energy performed by Prashanti using 5.6 million rows and 20 plus columns of data. You can see here the distribution of temperature. You can see here the hottest cities in India. You can see here a word map showing the most commonly reported weather conditions. And you can also see a map of India showing the different regions and the weather in those regions. Here's another example of analyzing e-commerce customer behavior. This is an even larger data set containing 42.5 million rows and 9 columns. And again, there are a lot of insights to be gathered from this data set. So the idea here is you want to pick some domain that is of interest to you or some domain into which you want to ultimately apply for jobs, find a large data set using the sources that we've talked about, work on your project, then document it, publish it online, and include it in your resume. So that's exploratory data analysis. Now, here's must have project number 2. You should try and build a business intelligence dashboard using tools like SQL, Excel, and a BI tool like Tableau, Power BI, Looker, etc. Okay. So, how do you build a project like this? You start by picking a SQL, CSV, or an Excel dataset. You can find hundreds of these online. Make sure that your dataset is large enough and make sure that it is unique enough, which means it's not already used in some course or tutorial. Then you want to perform some cleaning analysis and pivots within these tools itself. If you're doing it using SQL, then you want to write some SQL queries to perform this basic cleaning analysis and querying. If you're using Excel, maybe you want to do some analysis by creating new sheets using VLOOKUPs, maybe even creating pivot tables. So the idea here is you want to demonstrate your SQL or Excel skills while you're preparing and analyzing the data. And then once you get the data into the form where you want to create a dashboard out of it, import this data into a business intelligence tool like Tableau or Power BI or Looker. It doesn't matter which one you choose, as long as you're picking one of these, which allows you to create these interactive charts and dashboards. Then, using the different tables or the different sheets within the data, create interactive charts, which means charts on which people can select filters, charts on which people can hover to reveal more information, click on specific parts to get more information, and so on. And also make sure that each chart conveys some interesting insight. Once you've created these individual charts, you can then create a dashboard and you can then publish that dashboard online. Now, Tableau, for example, has a community called Tableau Public Gallery, where you can see thousands of Tableau dashboards that have been created and published by people. But if you don't have that option, you can also just take screenshots of the specific graphs and write a blog post or just write a simple report or put it up on GitHub or elsewhere. The idea here is to publish it online in some form and link it from your resume while you apply for jobs. So that's how you build a SQL and business intelligence dashboard. So here is one example of the kind of projects that Jovian Bootcamp participants have built. So this is analysis of the bookshop dataset. This is a popular dataset that is used for creating Tableau dashboards. And here you can see information like the top 10 selling books over a year, or the money spent in marketing in different genres, or you can find the authors with the maximum number of pages, and you can see the countries of residence of authors, you can see the checkout trend, and a lot of other information. Now, interestingly, this was not the only project built using this dataset. Here is another project built using the same dataset, bookshop. So, sales of several books over a year at a bookshop. And this is a completely different dashboard. So, that's the interesting thing about these projects, that you get to make it your own based on the kind of charts you like, the kind of information you're interested in, the kind of insights you want to showcase, and the kind of areas you want to explore within the same data set. So the same data set can be used to create hundreds, if not thousands, of different projects. So don't hesitate if you see that there are already some projects with the data set. You can still create a bunch of other projects too. Here is yet another example. This is a common pattern you'll see in dashboards where some important total metrics are shown at the top, and then there are some graphs that can be used to dig in and understand things a little better. So here is a different example. This is a sales pipeline dashboard. So here we are looking at how many customers are we are prospecting, how many customers are need to be qualified, how many customers have been qualified, how many customers have made a sale, and so on. And there are also some overall metrics at the top. Again, we will share the links to all of these projects in the chat so that you can explore them in more detail. And when you're building your project, you can use this presentation as a reference. Try to make your project at least as good as the projects that you're seeing here. Here's another example of estimated prevalence and incidence of Parkinson's disease in the UK. So this is a map. Along with the map, there is also a prevalence rate and a prevalence by age. And this is an interactive dashboard. So you can click on any specific county or district and you can see the stats for that specific district as well. So here is the must-have project number 3. You should be building a classical machine learning project. And I know some of you may be wondering here, why not deep learning, why classical machine learning, or why not maybe web scraping or something? So the reason we suggest building a classical machine learning project is because most of the data today is still in a tabular form. Most of the data today that companies need to build machine learning models on requires classical machine learning and not deep learning. So, in your role as a data scientist, you will most likely be working on tabular data and using classical machine learning techniques. So, that's one reason. Although it's good to know deep learning, it's important to first know classical machine learning. Then, the second reason is that while learning classical machine learning, you will build a strong foundation of the skills required to deliver a machine learning project end to end. Things like building a validation set, things like creating new features, tuning hyperparameters, conducting many experiments, picking the best results, combining and ensembling models, and so on. So, a lot of these skills are foundational skills that you build while building classical machine learning projects, and they help you with deep learning and other kinds of projects like recommendation systems and reinforcement learning, etc., as well. Okay, so you should definitely have a classical machine learning project, especially if you're applying for a data scientist role. So how do you build it? Well, pick a real world data set. Here, I would recommend picking it from Kaggle, and I would specially recommend picking a data set from a Kaggle competition that has already ended. So, Kaggle runs competitions every month, and you have now hundreds of competitions to choose from, and all of these competitions have data that has been taken from real companies trying to solve a real problem. So that's why it's real world data. So pick a large data set from Kaggle. And one other thing that you can do when you're working with a past Kaggle competition is once you've trained your model, you can submit it back. You won't show up on the leaderboard, but you can check your score and see where you would have landed on the leaderboard. So that way you can really test yourself, and you can prove yourself and prove to potential employers that you've built a good model by getting into the top 30 or 40% of the Kaggle leaderboard for a past competition. So pick a real world data set from Kaggle, formulate the machine learning problem statement, identify whether it's unsupervised learning or supervised learning, identify whether it's classification or regression, identify which are the input columns, which are the target columns, identify which input columns need to be modified in some fashion so that they can be used to train a machine learning model, and identify what should be the loss function, what should be the evaluation metric, what is a good baseline. So a lot goes into just formulating a machine learning problem statement, and that's an important skill to showcase when you're building a project. Then analyze and prepare the data for modeling. So you may have to maybe drop some columns of data, you may have to transform some columns, you may have to scale some of the numerical columns, you may have to remove some outliers, you may have to encode categorical columns, you may have to perform all sorts of preparation before the data can be used for modeling, because ultimately machine learning models can only work with numbers and they can't also deal with missing data, and you have to make sure you don't have multicollinearity. You have to make sure you don't have any columns that are directly correlated with the target and will not be present in the real world. You have to create a training set, a validation set, a test set. So a lot of work goes into just preparing the data, and then you create some new features wherever you can, and then you train some models, and then you iterate. So machine learning is an iterative process. You don't just pick one kind of model and go ahead with it. You iterate with different kinds of models, you iterate with different sets of hyperparameters, you create different kinds of features, and you keep trying to improve your score day by day, model by model. And finally, you summarize what you've done in the project, the different kinds of models you've tried. You try to explain why the different models have different results, why a certain model is the best model, which features are important, why your result is a good result, and your model is usable in the real world, and then document all of that and publish your project online. So yes, it is a lot of work. A machine learning project, a real world machine learning project, is not a joke. It often takes well over a month to work on. You will often require a lot of help and guidance as well. That is something that we uh, try to help throughout the life cycle of the project that people build. And then summarizing and publishing it online is a task in itself, but it sets you up really well for success in the real world when you're working with machine learning. So here are some examples of projects that have been built by Jovian Bootcamp participants. So Walmart store sales prediction, this is one project which contained about 500,000 rows and 14 columns of data. The objective was to look at store sales for several stores of Walmart over a few years and use that to make predictions on future sales. And the complicated parts of this project was that sometimes you have these discounts, so you have to account for discounts and how they would affect the sale, and sometimes you had these holidays and sometimes stores were closed, so there were all of these other factors that had to be taken care of. So Anushri built this project. She performed feature engineering, hyperparameter tuning. She was able to achieve $1,000 weighted mean absolute error, which got her into the top 14% on the Kaggle leaderboard, which is an amazing result, and that is a very usable model in the real world. So that's a great project to work on. And here's one on ad click and ad deal probability prediction. So this project was worked on by Deepa, where there was already information about 1 million plus ads containing 10 columns of data. So she had to perform feature selection, she had to perform some imputing to fill in missing data, she had to scale the data, encode the data, categorical features especially, then trained linear regression, random forest, gradient boosting models, and achieved an IRMSE of 0.247, which means you're trying to predict whether somebody is going to click on an ad or not. So she was able to predict that with an RMSE of 0.24, the probability, which is pretty good. So now, given new data, this model can identify whether somebody is going to click on an ad, and you can say if it gives a score higher than zero point 0.5, then this ad should be shown to that particular user. And if the model makes a prediction of less than zero point 0.5, then you should not be showing that ad. And this is something social media companies use internally to decide which ads to show you. So this is a great project to work on to demonstrate your machine learning skills. Then here's another one. This is where we're combining machine learning and finance. So David worked on this project where he looked at credit card default payment prediction. There were 150,000 rows, 11 columns of behavioral data, trained several different kinds of models, achieved a 93% accuracy. So, with 93% accuracy, his model was able to predict based on credit card spend and repayment information whether somebody is going to default in the future. And this got to the 20% on the Kaggle leaderboard. So, again, it's a great project to work on. But this also involved a lot of analysis. That's why you can see that pandas and plotly were also used extensively. We are sharing the links to all of these projects in the chat, so you can open them up, you can read through these projects, you can understand how they were done, and you can try to work on these data sets yourself just to challenge yourself and see where you are at. And here's another one on airline accident prevention using machine learning. This was done by Rishabh using 4.9 million training rows and 19.19 million test data. So small training set, but large test set. Again, a lot of different models were trained, and this project got to the top 26%. So I'm hoping you're looking at these projects and feeling impressed. And that is what a good project, a good portfolio project looks like. When you list this on your resume and your resume shows up in front of a potential employer and they look at it and they see that you worked on a project where there are millions of rows and you've trained all of these different models and you've achieved a good result that puts you into the top 20, 30, 40% of the Kaggle leaderboard, even if it is for a past competition, that is a very strong sign, and they are going to shortlist you immediately and they're going to then talk to you. And if all the projects that have been built that I'm showing here, the people who have built them have now gone on to start their careers as data analysts and data scientists. So these are the kind of projects that get people hired. They take work, they take time, but they are worth the effort. Now, once you've built your projects, you can showcase those projects anywhere you like. You can build a personal website. You can maybe showcase those projects on your GitHub profile, on your LinkedIn, all of these places, or you can also showcase them on your Jovian profile. So here's what a Jovian profile looks like. You can put up on your Jovian profile uh, some information about yourself. You can list the courses that you've completed. You can include a video resume as well. A lot of people do that. You can list all your projects, and you can then go and list your work experience. You can list your certifications and any Jupyter notebooks and your recent activity. So Jovian profile is a great place for you to compile all your data science work, especially if you're using Jupyter notebooks, and we recommend that you should, because they're a great way to document your projects as well. And this is a profile that you should possibly link to from your resume. That's what a lot of the bootcamp graduates do as they go out and apply for jobs, because we've optimize this so that anybody visiting your profile gets the best view of your data science work. Now, just to summarize, these are the must have data science and machine learning projects: exploratory data analysis and visualization, business intelligence dashboards using SQL, Excel, Tableau, and classical machine learning using Python, scikit-learn, and tools like LightGBM, XGBoost, etc. Here are some optional projects that you can also build depending on which specific role you're applying for, depending on what a particular job requires, depending on what your interest is. You may want to maybe build a web scraping project. That is also something that a lot of companies use, and that is also something that we have as part of the Jovian Data Science Bootcamp. You may build a deep learning project using PyTorch or TensorFlow. You should check out our course, Deep Learning with PyTorch Zero to GANs. It's a free course where you can learn a little bit of deep learning and build a project in deep learning. The reason this is optional is because most companies are still working with tabular data and they require classical machine learning, not necessarily deep learning immediately. And finally, you can also build a project on web development and deployment. And this is a great combination to do with a machine learning project or with a dashboard where you can not only build a model, but you can also create a simple application where people can interact with the model, maybe submit an input and see the output, and the model is hosted somewhere on the cloud, and you have an API to connect with the model. So we've recently put out a tutorial on web development. You should check our YouTube channel and you can learn this and you can work on this project as well. So these are all the projects that you can work on. These are all the projects that will help you create an impressive data science portfolio. And if you want to build all these projects, then, well, that's what we're here for. So if you're serious about building these projects and if you're serious about getting into data science, making that career transition, you should consider applying to our data science and machine learning bootcamp. This is a 6-month program where you will complete 600 plus hours of coursework, including 7 practical courses, 20 assignments, and 4 real world projects. Three of them you can see here: business intelligence, exploratory analysis, and classical machine learning. The fourth is an optional project that you decide depending on the area of your interest. And we help you not only learn these skills, but we also help you work on the projects. We help you pick topics. We help you make sure that the projects that you're creating are impressive. Apart from that, there's also one-on-one guidance and mentoring whenever you need it. You are paired with alumni mentors. Many of them have built the projects that we just showed you today, so you can talk to the people directly, talk to the alumni community directly, and you also get access to Jovian's network of hiring partners, which is something that is growing every day. So these are some of the tools and libraries that you will need to build these projects, and these are also the same tools and libraries that we cover in the bootcamp as well: SQL, Python, NumPy, Plotly, Pandas, Scikit-learn, Excel, Git, Bash, Tableau, Jupyter, and many more. And these are some of the companies that Jovian alumni today are working at. So if you learn data science and machine learning, and then you build impressive portfolio projects, and then you put them on your resume, create an impressive profile, impressive LinkedIn, impressive Jovian profile and resume, then apply to jobs, then you can absolutely break into data science. A lot of questions that we get are, do I need to have experience in the domain before I can get a job? No, projects are the replacement for your experience. Do I need to have a particular degree to break into data science? No, as long as you have a STEM bachelor's degree and you've done all this work, you can break into data science. So if you're interested in pursuing a career in data science, then you should apply to the Jovian Data Science Bootcamp. So we have a limited intake of of only about 40 to 50 for every batch, and we have a batch starting in a week. But you can definitely apply, and you can talk to an academic counselor, learn more about the program, figure out if data science is right for you, figure out where you stand in that journey. And if you're watching this webinar and you apply within the next 2 days using the link bit.ly/Jovian webinar exclusive, we'll post it in the chat. Then you will also get an exclusive discount. So if you're interested, if you're considering getting into data science, do apply. Otherwise, we also have a lot of free courses that you can check out. So you can just go to jovian.ai and sign in and check out some of the free courses. But if you're serious about it, if you need mentorship, if you need want to build great projects, definitely recommend applying to the bootcamp. Thank you all for joining, and I'll see you next time. And please post any questions or comments that you have in the chat, and we'll definitely answer them. Have a good day or good night. Bye.